My name is Mike Budzinski. I'm a senior PM for Azure API Management. Thank you for coming to my session, the last one of the day. So I'm surprised people don't have beers in their hands or any other beverages, but I'm glad you're here with me. We're going to talk about a little bit about API governance in Azure and in general. And then we'll wrap it up, and I hope you had a great conference. So first, federated API management. Can you raise your hand if you've have heard that term before? Federated API management. Anyone? One, two, okay. Not that many people. So what is it and why should you be aware of it, first and foremost? When we talk about API ecosystems in organizations, there is usually at least two different types. Oh, looks like the screen is not synchronized. Oh, perfect. Looks like there is two different types of teams that collaborate in API ecosystems in organizations. So first, we have the platform team. It's usually one team for the organization or a large part of organization. The role of the platform team is to set up the infrastructure to produce and to consume APIs inside organizations. And that means that the setup, the configuration of the infrastructure, and managing that shared infrastructure throughout the whole life cycle of that infrastructure. But the platform team also wants to ensure that the API portfolio that the organization owns meets certain criteria. For example, from the design and quality standpoint for APIs, security standpoint, maybe legal compliance like privacy, etc. They also want to have oversight and see what's happening inside that platform, what kind of traffic flows through that platform. Are there any cycles? Are there any trends? Is it booming? Is it declining? What are we doing right? What are we doing wrong? Are there any infrastructure issues, etc.? And then on the other hand side, we have usually many more teams, API teams. So teams that own and manage their own APIs throughout the lifecycle of APIs. So that means from design to implementation of APIs to publishing those APIs for consumption and then evolving them over the lifespan of those APIs. And depending on the organization, you might have one or two API teams, or you might have 500 or 1,000 API teams. It really depends on your organization. So since we have those two types of teams, now the question is, what do we do? Like the platform team wants governance and oversight. The API teams, they want to innovate, they want to move faster, they want to develop, and they don't want to be burdened and slowed down by that oversight. So the effective collaboration between those two teams is that you should be empowering API teams with autonomy to manage their own APIs. So give them freedom and let them innovate and move faster, but also ensure that centralized oversight from the platform team perspective. And this is basically what we call federated API management, right? So you have a central team with central oversight, but then you federate that management of APIs to teams that own APIs. So kind of decentralize it and not become a bottleneck as a platform team inside the organization. And when we talk about federated API management, there are three main services in Azure that I like to highlight that enable that federated API management. First of all, Azure API Management, Azure API Center, and Azure Policy. And we're going to dive deeper into all these three services right now. From API management standpoint, workspaces, which is a relatively new feature in API management, are that concept that enables federated API management. Previously or historically, API management supported centralized and siloed API management models. In the centralized model, all the teams collaborate inside one API management service without any isolation of control or data planes. So the conflicts arise either on control plane or on data plane where one team causes an outage for all the other teams because there's absolutely no isolation. So not really good for large enterprise API ecosystems and programs. The siloed API management model is total isolation. So you give each team their own API management service, but then the governance of that is very hard. The costs are very high, and it's hard to also implement API discovery across the organization. The federated API management model of workspaces is sort of evolution of these two. So each API team is given a workspace that they operate in, but still within a single API management service, which means that you can easily govern these APIs as a platform team and also apply unified API discovery. And workspaces enable that federated API management in Azure API Management through three main controls. The first one is the control plane isolation. So you can think of workspaces sort of like folders in API management from the control plane perspective that you assign permissions to for a specific group of users. So one folder with one API's named values, one set of APIs named values, policies, subscriptions, products, you can assign team A permission to that workspace. Another workspace could be owned by team B. And you as a platform team owner, you have access to all the workspaces, but the teams that develop APIs have access only to their own workspace, so they cannot mess with other teams' APIs. The second aspect of workspaces is optional API runtime isolation. So in API management, you associate a workspace with a workspace gateway. And that means that you can deploy multiple workspaces on one gateway, or even just one workspace on a gateway. And that allows you to segregate different workloads, make them more secure, more reliable. For mission-critical APIs, for example, you may decide that a certain workspace deserves its own gateway, so it's not prone to noisy neighbor issues, right? So you have that freedom to architect your systems for the criteria that you need, whether it's full data plane isolation, or whether you want to deploy more workspaces on one gateway. And the last aspect of workspaces to enable federated API management are the API platform team controls. First and foremost, API platform teams can apply a runtime policy that spans across workspaces. So for example, authentication or caching or set header or whatever kind of policy you would like to apply, you can apply it across workspaces, either all of them or selectively, and not have it overridden by workspace teams. The second platform team control is federated logging, and we're going to discuss it just in a minute. Also, centralized developer portal. So from workspaces perspective, developer portal is not aware of workspaces because all the APIs are surfaced in the developer portal. You can still control the visibility, but then, for example, if a developer portal user wants to get access to a specific API, that access is redirected to a specific workspace where that API is managed. So we still have a unified discovery plane for APIs, and that federation is happening on the backend side for administrative purposes. So here is just a brief overview of the architecture of workspaces. Like I said, there are certain platform team controls on the API management service level, and then workspaces also are a child concept of API management, and they contain APIs, products, subscriptions, etc., and they are potentially owned by different teams. And then you associate each workspace with a workspace gateway. You can map however you wish those workspaces. And let's play a short demonstration of workspaces in action.
Workspaces enable federated API management by providing autonomy and isolation for API teams while ensuring centralized governance and oversight by the platform team. Workspaces are like folders, grouping APIs, and isolating administrative operations. You can assign workspace members one of the built-in roles like API developer or product manager, or a custom role to grant them access to manage APIs and related resources within a workspace. By default, API teams have full autonomy to manage workspace APIs from design to implementation of policies, debugging, monitoring, publishing in the developer portal, and even managing consumer access. When a developer portal user subscribes to a product, that subscription is automatically created in a workspace the product belongs to for approval and management by the workspace team. A workspace needs to be associated with a workspace gateway to deploy its APIs. A workspace gateway can host anywhere from 1 to 30 workspaces, allowing for balancing the security, reliability, and cost of deployments. For example, mission-critical workloads can be deployed on a dedicated gateway to ensure data plane isolation from noisy neighbor issues, while other workspaces can run on shared gateways. Each workspace gateway is a standalone Azure resource with a control plane decoupled from the API management service. This means that you can manage gateway configuration even when your API management service is experiencing an outage. Gateways support features like private networking, autoscale, and metrics. Workspaces also allow for decoupling of API lifecycle. Each workspace can be powered by a distinct CI/CD pipeline. While API teams operate in workspaces, platform teams maintain centralized controls. They enforce runtime policies for APIs across workspaces on all or selected workspaces. Federated logging allows platform teams to view logs for all APIs managed in the platform and Azure Log Analytics. Workspace teams' access is scoped to their API's logs only. Unified Developer Portal surfaces APIs from all workspaces, while still supporting visibility controls based on the user identity. Platform teams can also manage shared infrastructure, like gateways shared by many teams in the organization, and can audit or enforce configuration at scale using Azure policy.
All right, so now I just want to highlight a few announcements that have recently taken place. The first one is the Shared Workspace Gateway. So the Shared Workspace Gateway allows you to associate up to 30 workspaces with a workspace gateway. And again, that's for the scenarios where you would like to balance the cost, security, and reliability of your deployments, right? So there are some reasons where you might want to choose some situations where you might want to choose a dedicated gateway for a workspace. For example, for mission-critical APIs to fully isolate it from noisy neighbors. In some cases where you want to deploy more workspaces on one gateway to optimize the cost of that deployment. For example, you can also use multiple gateways to isolate different types of requirements, for example, networking requirements. So you can have one gateway that's injected into a virtual network for internal traffic only, and then you can have another gateway that has external VNet integration for external-facing traffic. Or both could be injected, but you want to separate those two different kinds of traffic for different use cases and workloads. So very powerful feature, very flexible, allows you to model your deployments and architectures to meet the enterprise requirements. That has already rolled out in April, so a couple of months ago, and should be available for use with workspaces everywhere where workspaces are supported. We also announced several new features at Build a couple of weeks ago. So the first feature you already saw in the demo, federated logging. This feature allows the platform teams central visibility into logs across all workspaces in the API management service, but the workspace teams have visibility into their own workspace logs only. Okay, so again, we have that federated aspect with scoped permissions to logs for workspace and API teams, and centralized visibility for the platform teams. That's supported through Azure Log Analytics. The second feature that we announced are the gateway metrics. So now gateways support CPU and memory percentage metrics to allow you for better scaling decisions. Related, they also support auto-scale. So you can automatically scale your gateways based on those metrics or based on a schedule. And lastly, we are also building out workspaces support across regions. We just enabled workspaces in West Europe, which is a very demanded region. So if you have workloads, especially in Europe, we already support several of these regions, including West Europe, UK South, I believe Norway is also supported, and a few others. So this is just a diagram how the federated logging works. So each workspace has, all logs are stored in a log analytics workspace, and each workspace access is scoped to a certain subset of logs that maps to logs for the APIs managed in that workspace. For the platform team, they have access to the log analytics workspace all up, and they can see all the logs across all workspaces. And lastly, I just want to pre-announce a certain functionality here. So you heard it here first, hasn't been publicly announced anywhere. Workspaces are now available in Premium V2, which is a new API management tier, which became in public preview, became available in public preview, also at Build, and now workspaces are available in Premium V2. At the moment, that availability is only through programmatic access. So you can use management APIs or ARM or Bicep templates. But rest assured, UI support is coming soon with the official announcement, probably in July, but you can already start using workspaces in Premium V2. And then we are also working on a bunch of other improvements. This is just the immediate roadmap, what you should be expecting in the next few months. And then we have many more later on that will become available also throughout the year. So we are working on adding more regions supported in workspaces. Workspaces will also soon support custom hostnames, so we'll be able to define custom hostnames for workspace gateways. Manage identity will allow you to isolate identities for your workspaces. So each team, each workspace can have a different managed identity, virtually isolating those identities and making your APIs and workloads more secure. That will also allow you to connect to backends or key vaults, for example, for certificates or named values. And lastly, workspaces are also coming to Defender for Cloud. So that will be part of Defender for Cloud offering as well, just like API management is today. All right, so that's on the workspaces topic. Then the second piece that I mentioned is that enables federation of API management in Azure is API Center. API Center is a relatively new service that we introduced in addition to API management. And API Center allows you to federate inventory of your APIs from various locations. So first of all, APIs of various lifecycle stages, from design development to production ready, as well as even APIs that might be retired. APIs that are deployed anywhere. They could be deployed on Azure and managed with Azure API Management. They could be deployed on Azure and not managed, or they could be deployed in even other clouds like AWS or RPG. In fact, API Center actually supports synchronization of API inventory from API Management, Azure API Management, and AWS API Gateway. So if you use these two solutions, you can aggregate your API inventory in API Center with full synchronization. If you use other API management platforms, you can still onboard those APIs into API Center. API Center also supports the concept of metadata. So that allows you to better structure your API inventory and to make it more browsable, more organized, especially for the purpose of discovery and for the purpose of governance. In addition to that, API Center also supports API design compliance. That means that you can define certain rule sets for API design and then audit and enforce that API design with API Center, as well as shift it left through integration in Visual Studio Code with the Visual Studio Code extension. So when developers are developing and building their APIs, designing those APIs, they can check for conformance with your organizational API design rule sets as they're building those APIs. So not post factum, but at the moment of building the APIs. We also support integration of AI through GitHub Copilot to enable easier creation of APIs, for example, open API specs, and so on. And lastly, having that centralized inventory of APIs in API Center, you can also use API Center to enable discovery of these APIs across solutions, clouds, deployment locations, and lifecycle stages. So you can federate that discovery across platforms as well. And here's a short demonstration of Azure API Center.
Many of our current Azure API Management customers have multiple APIM gateways running across different lifecycle stages, like development, testing, and production. Managing these gateways globally can be quite challenging. This is where the need of a centralized API inventory solution comes into play. Customers can easily integrate their existing Azure API Management solutions, pulling all of the information from these gateways into API Center. Depending on the lifecycle stage, customers can customize the integration. API Center also supports the concept of API versions, ensuring that all assets from API Management are correctly represented in API Center. In addition to Azure native integrations, we also offer cross-cloud integrations such as Amazon API Gateway. Similar to the Azure API Management integration, customers can link their API center to an AWS gateway solution, pulling the information in and centralizing everything in one place. API changes and updates are very common, such as deleting an API on the gateway. With our integration between these two services, we ensure that all these changes are reflected, keeping the inventory up to date. Beyond inventory capabilities, API Center offers API design time governance features. With API analysis, customers can analyze their API definitions, showcasing potential error or warning messages. We use Spectral as our API linting engine to analyze these API definitions based on Spectral default rules. We understand that every customer has unique needs and requirements. With API Center, we provide organizations with a tool to modify these style guides, adapting them to their specific requirements. In addition to overall API analysis, customers can also view detailed reports on an API definition level, gathering more concrete details on errors and warning messages.
All right. Who has heard about API Center here for the first time today? Okay, quite a few people. Definitely a service worth looking into, and I've also got great news for you because we are bringing Azure API Management and Azure API Center closer together, and we have two parts of that. So the first part, it's already supported that the free tier of API Center will become perpetually free with an API management service. So if you have an API management service, you can use the free tier of API Center without time constraints. And then the second part that's coming soon, that we are working on right now, is that if you have API management standard or premium, the standard tier of API Center will be included with that. So hopefully, that will encourage you even more to use those federation and API management capabilities of API Center with API management. All right, and then the first piece of the federated API management puzzle is Azure Policy. So probably not a service that you hear about very often, but it is quite interesting and applicable to this use case. So Azure Policy basically allows you to implement certain best practices or security controls or configuration controls across a fleet of your resources, such as API management services or APIs within API management services. And that can be, for example, enforce use of secure protocols like HTTPS or WSS instead of HTTP or WS, right? You can also enforce the maximum number of API versions to make sure that your API portfolio doesn't explode with hundreds of API versions for each API, and so on and so forth. So you can use built-in policies to do that, or you can build your own custom policy definitions for your specific use cases and needs. And then those policies can either enforce the compliance on new resources or new management operations on these resources, or they can flag or audit that compliance for the resources that already exist. So you have kind of two modes. You can either enforce it or you can audit it based on your, again, goals and objectives. And we already provide, I don't remember, probably like 10 or 20 built-in policy definitions. Plus, like I said, you can create custom ones for your use cases. All right, and then there are a few other puzzles to that federated API management as well. One of them is Microsoft Defender for Cloud, which allows with the application of federated API security across API management services. So Defender for APIs is a part of Microsoft Defender for Cloud. It is an offering that provides advanced API security for your APIs, especially managed in API management services. First and foremost, it provides threat detection. So it contains machine learning models that represents some severe threats, and they analyze your API traffic to detect those threats in almost near real time. And then the second part of Defender for APIs or Microsoft Defender for Cloud is API security posture analysis. So they discover APIs that are unauthenticated, externally exposed, that serve sensitive data, are maybe dormant, don't receive any traffic, etc., just to create that federated API inventory from the security standpoint, so you understand the inventory of your APIs and how it maps to some threats or vulnerabilities. And Defender for Cloud team has been very busy as well, adding more API security controls. The first one that became available in the past year is API security posture in Defender CSPM offering. So if you have Defender CSPM already enabled in your organization, now you get that API security posture analysis included as part of that offering without the need to buy Defender for APIs plans separately. So you can get those benefits of classifying APIs based on the sensitive data, unencrypted endpoints, etc., to get that inventory overview from the security standpoint. The second feature that's new is the discovery of API-led attack paths. Basically, we map your APIs to backend services that power those APIs, and that allows you to better understand what will go wrong and which services will be affected if your APIs are breached, right? So certain, for example, Kubernetes clusters or functions or web apps or whatnot you use as backend services may be more vulnerable or more important to you than other services. And with that information, you can prioritize the risk remediation or the threat remediation mitigation based on that information. Oh, we lost the video. Oh, we have it back. Perfect. And then the last part is the discovery of unmanaged APIs. So we are working also, coming very soon, on bringing some of those capabilities also for APIs that are not managed in Azure API Management. So we'll be discovering APIs across Azure App Services, like function apps, logic apps, web apps, and letting you know about these APIs, because in some cases you might not even be aware that those APIs have existed for the past decade. And those APIs actually are very vulnerable, and they may be a very sensitive point for attacks, just because they may not be maintained properly, they may not be managed properly, they may not be observed properly, maybe they're not even upgraded, right? So this is a very important aspect to make sure that you understand which APIs are not managed, where they reside, and hopefully bring them under management so you have a better observability and insights into these APIs. All right, and then, quite a few announcements already in API management. So what else is new, right? Well, quite a lot, to be honest. And I don't want to, read this slide to you, but I just want to demonstrate. These are some of the capabilities that we added since we were here last year on the stage a year ago. We have been very busy as an API management team, adding capabilities across various parts and scenarios of the product. So part of the story is the federated API management workspaces, making API management intelligent with various copilots. For example, with G8, Microsoft Copilot in Azure for policy authoring. So you can interact with the Copilot in the Azure portal and ask it to write, policies in API management based on natural language prompts, or to explain policies that your colleague wrote, or to troubleshoot your policies, or to optimize your existing policies and more. Similar capabilities are available in GitHub Copilot in Visual Studio Code extension. We also added a lot of capabilities around the security. We added a lot of enhancements to validate Azure AD token and validate JOT policies. We added a lot of enhancements to Defender, like I said, and many other capabilities from the security standpoint, including Premium V2 preview with virtual network injection, as well as private link capabilities. We also have been working on the developer story, making API management more user-friendly to developers and making our developers more effective and more efficient. For example, we have a tool that allows you to write API management policies in C# and then compile them to the API management XML syntax. And that allows you to unit test those policies and make them part of your source control as C# code. But that's not all, right? We also have AI. So we also have been busy adding AI capabilities. And there was a session about it today. I hope you had a chance to attend that session as well. We added so many AI capabilities, including in the gateway, including MCP servers, and so on and so forth, that it barely fits on this slide. And then we also added more capabilities to API Center and the cataloging experiences across API Management and API Center. So as you've seen, we've been really busy throughout the past year, and I think it's a very exciting time for API Management, for API Center as well, for in general API Management concept with the AI also becoming potentially a producer and a consumer of APIs, and the organizations shifting to federated API management. I think we are adding a lot of capabilities to support you in those various use cases. So all of these capabilities are brand new since last we were here in June. We're also working on a few other features that are going to become part of API management very soon. One of them is the service bus integration. So you will be able to bring service bus queues and topics under management as APIs with Azure API Management. So that allows you to apply policies to route, HTTP requests to those service bus queues or topics, as well as apply observability, publish them for consumption in developer portal, secure them with subscription keys or OAuth, and maybe inject some metadata with headers or query parameters. So that's a very interesting new use case that hopefully will be applicable, especially for integration scenarios. And we also have a short demonstration of that. And this is what you should expect coming soon.
Welcome, everyone. I'll walk you through how we're using Azure API Management to simplify integration with Azure Service Bus without relying on additional compute like functions or logic apps. Let's dive in. Many of our customers want to trigger queues or topics in Azure Service Bus from their APIs. But today, they often deploy Azure functions or logic apps just to do that. This adds latency, cost, and complexity for simple use cases. Our goal is to simplify that workflow. With API Management's policy engine, you can now enqueue messages directly to Service Bus. You can secure the API, route messages, and return a response, all within API Management. It's powerful and efficient. Here's what's happening under the hood. A client sends a request to an API managed by API Management. It applies a policy that pushes the message directly into a Service Bus queue or topic. Let's walk through a demo for this capability. Here, we've set up 3 APIs, each showing a different real-world messaging pattern. Get/carinfo sends a log message to the auditing queue. Post/order enqueues full order data into the orders queue. Post/speed camera pushes telemetry to the speed registrations topic with tenant metadata. We'll walk through each call, trace the policy execution, and watch messages land live in Service Bus on a second screen. Let's take a look at the first policy, get/carinfo. This simulates a VIN lookup. The policy extracts the subscription ID and sends it to a Service Bus queue called auditing. Let's send a request. In the trace, we see send Service Bus message fired, and the payload matches the subscription ID. Now switching to the queue. And yes, the queue received the exact ID we sent. Next up is post/order. This simulates an order submission, but instead of calling a backend, the policy captures the full JSON body and sends it directly to a queue named orders. We then return a quick 204 no content response to the client. This is a classic fire and forget pattern, great for decoupling front-end requests from back-end processing. Let's send a request with some sample order data. In the trace viewer, we see the send Service Bus message policy executed with the correct payload. And now on our second screen, we can see the full order message has landed in the orders queue. Our last API is post/speed camera, simulating telemetry from a speed sensor. Here, the policy forwards the entire request body to a service bus topic named speed registrations and attaches a custom message property called customer, pulled from the X-tenant request header. This lets downstream subscribers filter or route messages by tenant, enabling powerful multi-tenant event flows. Let's send a request with a sample telemetry payload and X-tenant, Contoso, in the header. Looking at the trace, the policy ran successfully, and the message property customer was set to welcome everyone. I'll walk you through how we're using Azure API Management to simplify integration with a sample telemetry payload and X-tenant, Contoso, in the header. Looking at the trace, the policy ran successfully, and the message property customer was set to Contoso. Switching over to the second screen, the topic subscription received the message, complete with the correct telemetry data and tenant tag. So with just policies, we've triggered 3 asynchronous flows, each one traceable, secure, and backend free. This capability enters preview in Q3 2025, and we're excited to see what you'll build with it.
All right, so that's coming to API management near you in Q3, so that's starting July, pretty soon. So hopefully quite useful to you. And lastly, we are also working on integration scenarios with SAP through API management. So API management allows you to front your SAP APIs and mediate them and apply all the policies, all the observability and security and governance controls and discoverability, etc., of API management to your SAP services. So you can fully utilize the Enter ID authentication. You can integrate with API Center, for example. You can publish these APIs also to like Power Automate connectors. And yeah, a lot of use cases as well for publishing and managing SAP APIs with Azure API Management. If you're interested in more details or if you have any questions about the specific functionality, you can reach out to Martin. His email is on the screen, and this QR code should also point you to the right resources. And with that, I wanted to thank everyone for joining the session and coming to the conference. And I'm excited to see you next year as well. And I'll be around here if you have any questions. I know we finished a little early. I cannot keep you here. I know it's the end of the conference. You're just waiting for the closing remarks. And thank you for being here.